Hello, back in the 90s, the de facto web server was Apache, and it spun up a new process per connection, which means a lot of memory and CPU overhead in creating new processes. So scaling it past 1,000 connections is very computationally expensive. For fun, I built a very minimal Python version of NGINX, and I call it Minginx, and I'll quickly take you through that. So the code here has a master worker architecture, which means a master does some config work and then spins up workers to do the actual work. Master creates a socket and sets that socket to be inheritable, which means the children can also use that socket and share the same socket. Then we fork the process, change the executable to be worker.py, and provide the socket file number and the public directory arguments. The worker at a high level is also pretty simple. It gets the socket file number, sets the listening socket based on that, adds a selector on the listening socket, so that waits for an event read that comes by. Once that comes by, you run the accept function on it. Accept function accepts the connection and then runs a read on it. And the read will basically get all the data out of the HTTP connection that was made. It'll have a bunch of headers and stuff. I don't really do that kind of HTTP parsing. All I'm doing is extracting the file name out of it. I make a header and I send that header, then I send the file. And then I close the connection. And that's it. Now let's see this actually working. I want to run that, and that's going to spawn 4 workers and wait for my requests. Then I'm going to go on Chrome. I'm going to run localhost 3000, and you'll see that I get an HTTP 400, which is because I haven't defined the file that I want to get served. Then I'm going to say index HTML, and then that's going to give me the index HTML. I can also say script JS, and that serves me the script. And these files are defined in the public folder. Efficiency here comes from a few things. So the fact that it's event driven, workers use the select or the ePulses calls, and they don't keep polling the socket. Instead, the workers get woken up when the socket has new data to be read. When you're sending a file, usually you read the data into user space, then that file data gets written onto the kernel space cache, and then that gets sent through the socket. But here, since we use a send file, all of that work is done in the kernel space. So no extra user space overhead. And finally, we don't spin up a new process per connection like Apache did. And so having n constant processes ensures that we don't have any process creation overhead. So check out the repo, run the code, and see for yourself how modern web servers work at a fundamental level. Peace.